So for part A of question 6, we are asked to find the range of f of x where graph is shown here. So for the range, we're looking at the possible y values that it can take, and we can see that the y values are anything above this vertex. So to find the coordinates of that vertex there, have a look at the function, and we can see that this modulus part here is always going to be greater than or equal to 0. In fact, it will equal 0 when x equals 4. So that must be 4 there. And when x equals 4, f of x is minus 5. So that's the smallest possible value there. And it is allowed to equal it. I have got no restrictions on the domain here. X can be anything. And so the range is f of x is greater than or equal to minus 5. And we could add in f of x belongs to real numbers. Okay, for part B, we are putting f of x equal to minus 1/3 x plus k. This is a really typical exam question. It's very similar to question 13 from exercise 2A that I set you. It's really important that you do as much of the exercises as you can, the questions I set you, so you're getting experience of the breadth of possible exam questions. So for this one, we're basically looking at the straight line y equals minus 1/3 x plus k, and where it crosses this modulus graph. So we're told that it has two distinct routes. It could look like this, where its gradient is minus 1/3. It crosses y-intercept at plus k. Now that k, depending upon what it is, it could be up there or it could be down here. Now if it's right here at the vertex, this is where it would just tell us it's only got a single root or a repeated root, okay, if it just touches the graph. If it's below that modulus graph, then there would be no real roots to the equation. So we're told it's got two distinct roots, so we can assume it's somewhere above that minimum vertex. So we've got 2 points where it crosses, and we're basically going to solve the two equations that arise from that. So the first one comes from this positive part of the modulus graph. We're just assuming that x minus 4 has given us a positive value, so it's equal to that. And the second one comes from the reflected part of that graph. So we know that our solution, our value of k, satisfies both of these equations because these two distinct roots exist. So we just simplify each of those. So in our first equation, we get down to this, 10/3 of x minus 17 equals k. And in the second version of the equation, so we've now got two equations in two unknowns, and we can actually solve these to find the values of x and k. So actually solving these simultaneous equations gives us x equals 4. So it gives us the point when we are at that vertex. And if I plug that back in, I can work out what k is. And we find that k is equal to minus 11/3. So that is the value of k, which gives us the line that just touches the vertex of that function. We're asked for the possible values of k, so we're looking for a range of values which will give this two distinct roots. So it's basically anything above that that would lift that line up. So it must be for k is greater than minus 11/3.